Hello, this is Mrs. Rouse, and this is Investigation 10, Using a Compass and a Straight Edge, Part 2. So in Investigation 2 in the fall, we used a compass to draw circles and regular hexagons and a triangle and a circle. Today we're going to bisect or divide in half a segment and an angle and inscribe a square and a regular octagon and a circle. So we have our compass, our ruler, and our protractor. Here we go. Protractor. Okay. So A says, well, it says to construct means to use a compass or a ruler to make geometric figures. Use a separate sheet of paper for the constructions. Label constructions A through D attached to this investigation. So let's get started. It says A, I'm going to put this over here so I can work on it. Let me pick up my pencil off the floor. So let's see. A says to bisect a line, construct a perpendicular bisector to divide a segment in half. So use a metric ruler to draw a segment 6 centimeters long. So let's see. 6 centimeters. Why is there a fuzz there? 6 centimeters. Right here. Okay. Label the endpoints A and C. A and C. Set the compass for 3.5 centimeters or 1.5 inches. So that's, centimeters is on this side. Inches is on this side. So let's see, there's 1.5. Is that 3.5? Yeah, okay. So a little longer than half of the segment. Place the pivot point at either A or C. And draw a light arc. Okay. And then it says put it at the other one. Don't move the thing. Draw another arc. Oh, these have to be longer. Sorry. These have to be kind of long because we're going to draw a line. Okay, so let me go back and do this one right. There we go. So it kind of has a little fish. Great. Now draw another arc through this. Okay. Draw a line through the 2 points. So we have this point and this point. I'm just going to draw a line here. So it looks like that. It says this line divides A and C into equal parts. Label the point where the line intersects with AC and call it B. Okay, so that's the whole first page. Let's go to the second page. It says use a metric ruler to find AB and BC. Here's your metric ruler. You're going to look that up, write it down, look that up, write it down. Where the line and segment intersect, 4 angles are formed. What is the measure? So they want to know the measure of this angle. And these are going to be 90-degree angles. Why is the line you constructed called a perpendicular bisector? The line is perpendicular to the segment that divides the segment in half. So that's everything up to B. Let me see if this is actually working. Oh, praise the Lord. Okay, inscribe a square and a circle. Draw a dot on the paper for the center of the circle. Okay. Set the compass for 2 centimeters. So centimeters is on this side. 2 centimeters is right here. Okay. And draw a circle. Lovely, great. Okay, here. Just draw. It's going to be kind of small. Oh, I messed up. That's okay. Okay, I'm going to turn this. Let's see. Did I mess this up? Okay, let's see. I'd rather turn the paper. So, okay. Let's see what we're doing there. Give me either anywhere. There we go. Lovely. I'm gonna erase my little issue here. Okay, so we have a circle. Use the ruler to draw the diameter. So that's just gonna be here and straight across. That's my diameter. Set the compass a little wider than the radius. So if this is the radius from here to here, I'm gonna set it a little wider, so like right there. Place the pivot point on one end of the diameter, okay, and draw the arcs like we did up top. Ooh. Gotta be kind of long, and then I'm gonna put them on the other end over here and do the same thing like that. Okay, and then do the same, okay, and then so then this goes like this. Draw a line through. The same thing for the other, draw a bisector as in activity A. Now, two diameters divide the circle into quarters. Draw chords between the endpoints of the two diameters. So like from here to here, and from here to here. Oh, the post won't let me move it. Okay, there we go. Okay, and then here to here, and then here to here. Okay, so now we have a, oh, that's weird looking, but okay. Now we have a square inscribed, okay. Each angle of the square is inscribed in the circle. What's the measure of each angle of a square? You're welcome to measure this with your protractor if you want to, but it's gonna be 90 degrees. So that's the bottom of the first page. Flip it on over. Within the square inscribed in the circle are 4 small right triangles. Yes, they are. The two sides of each triangle are radii of the circle. If the radius is 2, then, so what they're saying is like, here is a triangle right here. It's a right triangle. And this side is 2, and this side is 2. So what is the area of the triangle going to be if the base is 2 and the height is 2? That's 5A. How can we find the area of the inscribed square? We add the areas of the 4 triangles. So once you find the area of one, you would multiply it by 4. So the area of the square is however many centimeters you get. Okay, so that's A and B. We're on to C. Okay, let's see. We'll scooch it up. Let me see if we can put C on the bottom here. Okay. Oof, oof. C. It says, bisect an angle. Use a protractor and a ruler to draw a 60-degree angle. So the first thing I'm going to do is I'm just going to draw a line. It doesn't really matter the length of the line. But then I need to draw a 60-degree angle. So I'm going to put this on the end, and I'm going to line up the bottom with the line I drew, and 60 is right here. So then I'm going to attach that, I guess. So that's 60. Okay. Compass on the vertex of the angle. Draw an arc that intersects both sides of the angle. Label the vertex V. Okay, so this, I'm just gonna put this, what is this on? I put it on, let's see, I'll put it on 3 inches or, I can't see, 7.5 centimeters? Okay, that's too far. Let's try again. Let's do 2 inches. Okay, I don't know. I don't know what I'm gonna need this for, so. Here we go. There we go. What a beautiful art, except that it's kind of messed up. So let me erase my messed up part. There we go. So this is R, and this is V for vertex, and this is S. Label the using R, set the compass to more than half the distance from R to S. Okay, so if this is R to S, then we want it just more than half. So like that much, I guess, okay. Okay, place the pivot point on R and mark. Hi. I'm making a video, so just so you know. And make a mark. Oh, shoot fire. There we go, like that. And then, I don't think I did this right. Make a mark. I did the arc. What's the distance from R to S? Oh, R to S is this way. I'm a goober. There, more than half would be there. R to S is this way. That's B to S. I'm gonna erase this. Okay. More than half. Did you need me, love? Oh, okay, sorry. So then let's put that out there. And then we'll go over to R. Okay. It's both across. That out there. Perfect. The same. Okay, so this is gonna be T. And rate. Okay, and this is draw a line through VT. V and T. Okay, so this. Okay, ray VT divides this in two, so I've just done an angle bisector. Okay, great. Use a protractor to measure the angle you drew. Well, I drew this angle at 60 degrees. Let's see if it's still like that. It's close, yeah, there's 60, so 60 degrees. Measure the two smaller ones. So this one, you can measure from here, and then to measure the other one, you kind of turn it up like this. See, my little whole thing is on top of V, and I'm lining up my line, and I have, so you measure both of those. In this activity, you constructed an angle bisector. Why is the ray called an angle bisector? The ray divided the original angle into two congruent angles. That is the ray divided the angle in half. Okay, so that's page 2. We're getting close. We just have D left. So this is, I'm gonna put this over here, start this down here. Let me see if I'm still in the field. Yay. D is the last one. Let's see. D is inscribed a regular octagon. Good gravy. Use a compass and a ruler to make a circle in a diameter, blah, blah, blah. Okay, so let's see. We want a fairly, I want a pretty big circle. So let's see, 2.5 maybe? Okay. Okay. Oh, I messed up. Where's my little, there it is. There we go. Oh, okay. Well, there's a circle. Okay, great. I'm gonna erase this part. Great. And use a compass, ruler. Okay, so there's my little dot right there. I'm gonna go ahead and do this like this. Okay, there's my diameter. So this is M, this is XZ. Okay, use the diameter endpoints to make a perpendicular bisector of what? How did we do that? Top, oh, fart. How did we do that? A little wider than the radius? Oh, that's what we did. Okay, so if this is the radius, we got to go a little bit wider than the radius. So that's radius. So a little bit wider. Okay, and so my point's on Z. So I'm going to go like this. It's got to be pretty big, like that. And then I'm going to do it over here too. So my point's on X. Oh, it kind of came off of X. Hold on. Oh, goodness. Okay. Got a little bit of issue there. Not bad. Okay. So, bisection and points top and the bottom. Okay. So we're gonna do here, like this, and this is Y. That's all I know. Draw intersecting arcs outside the circle from points Y and Z and X and what? So from Y and Z, I don't know. From X and Y, like that. And then the same, like this. I sure hope this works out, because I'm a little bit on the lost. Oh, I did it too, not. Okay, let's go back here. That's got a cross. Cool, lovely. Okay, with a ruler, we're gonna pass through these. Oh, I need a ruler. Can't pick it up. This. Okay. And then here we have like this. Okay. Did I do it? Yes. Great. Lots going on there. Okay. It says, what is the measure of each central angle formed? So, like this part, that's not a central angle. That's just... But like this is a central angle, this is a central angle, so we can take our, this and put it right there. And the central angle goes out to here, so it looks like 45 to me. 45? Oh. Okay. With a ruler, draw chords from point to point. Okay. So this is what we're gonna do. From here to here, we're gonna draw a point, and from here to here, draw a line. Did I say point? I think I said a point. Boy, this octagon's gonna look pretty strange. We just kind of keep connecting the dots here, guys. Like this. Oh, how pretty is that? The octagon is divided into how many congruent triangles? 1, 2, 3, 4, 5, 6, 7, 8. Use the inscribed octagon to answer 10 through 14. Segments MW, what in the world? That's W. This is M. MW and MZ are the same. Okay, so that means that this is a radius and this is a radius. So these are the same. So a triangle that has two of the same sides is, and it starts with an I. Okay, flipped it over to number 11. What is the measure of WMZ? WMZ, I already measured it, it was 45, which is 1/8 of maybe 360. I would take 360 and divide it by 8 and see what you get. What is the measure of MWZ? So this one. So we would put this on the W, which is the vertex. And this goes up to, it looks like 70 to me. And then MZW, so here, put this on the Z, whatever's the middle one. And that goes up to maybe 65. It may not equal what it's supposed to equal. The angles of a triangle total 180, and you would have to add these three up to get angle WMZ. Oh, no, you're supposed to find WMZ. The measure of angle MWZ is equals half of 135, or whatever half of 135 is. What is the measure of W or YW? Oh, this. Well, this is probably 140. What is the measure of each inscribed angle formed by the sides of the octagon? Inscribed angle formed by the sides. So that would be this whole thing. Each angle that's that side. And that's 14. And that is the whole thing. So you'll want to make sure that you fill this out, right? That you turn this in, staple it, and that you turn this in. Let me know if you have any questions.